After having our decision variables specified, as we discussed it just recently in the previous video, and we noticed that, okay, we need to specify the number of bond 1, the number of bond 2, the number of bond 3, and amount of money we invest in saving account are our decision variables. Now we are good to go and discuss the objective function. About the objective function just needs to be the mathematical expression of the goals, the objective function you have. Here we have the objective function, as you can see in front of you, that it says how to minimize the cost of satisfying all the company's obligations. So it is the one. And now, after that, we notice that the decision variables are the number of bonds and amount of investment. So here we can say the total cost that we have is, I'm sure you agree with me, that they have a relation with the number of bond 1 that we buy, number of bond 2 that we buy, number of bond 3 that we buy, and also the amount of money that we invest in a saving account. I'm talking about the cost that we have. We buy B1 bond 1, B2 bond 2, B3 bond 3, and S1. And also, let me show you this here, just in case you forgot it. As you can see, just now at the beginning of year 1, we need to pay $430, in fact $430,000 now. So the total amount of money that we need to pay is this one, and also 430 bucks that we pay. But how much we need to pay for bond 1? It depends on the price of bond 1. What is the price of bond 1? The price of bond 1 is 1150. That we are going to convert it to K measure. So it would be 1.115 B1, because everything is K measure. What about the price of B2? Price of B2 is $1,000, so it would be B2. The price of B3, I guess it was 1350, so it would be 1.5 B3 and plus S1, the amount of money that we put in that, plus 430, that it is already in the K measure. So now we have our objective function. As you can see here, mean that the total dollars required to meet the retirement plans, 8 years obligation, as you can see in front of you, minimizing F, that is equal to the amount of money that we pay for bond 1. As you can see, they are the same. Just here, this one is extra typo. And after that, it goes for the number of B2. You can see they are the same, plus 1.35 B3, the amount of money that you put for B3, plus S1 plus 430. So now you have your objective function. Before you proceed to the next slide, make sure you are completely caught up. So pause, replay, or anything like that. After our objective function, now we have our decision variables. After that, we got our objective function that is in front of you. Now it's the time to go for the constraint. The main constraint that we have in this problem are the monetary demands that must be satisfied. What are those monetary demands? You can see them in front of you. For year 2, you need to have 210. For year 3, you need to have 222. For year 4, you have 231. For year 5, 240, and like that. They are the constraint. You need to define that money in a way that the cash flow that comes from the interest from bond, interest from saving accounts satisfy these amounts. And remember, my friends, you got your bonds here. Okay, you got your bonds here. One of your bonds is mature after 5 years. So it means that when we go you bought them 1 year, 2, 3, 4, 5. So you get one maturity of your bonds here. One of them was for 6 years, so you get the second one mature at year 7, and you get the last one mature at year 8. All the things needs practice, needs re-listening, re-watching, re-practicing, because it's a new chapter and with many points regarding the mathematical modeling. So please be patient with yourself while you are learning. Okay, now let's go for this constraint that we have, and let's start with monetary demand of year 2. Why we skip year 1? Because we already paid for year 1 that 430 bucks that we discussed it in the objective function. So for year 1 we have no problem, we already paid it. Okay, in this slide, you will see the monetary demand of year 2, and I want you to do the monetary demand for the following years based on the things that I'm telling you here. This is the monetary demand that we have, and we are here, and we are here, and we want to see what happens. It is year 2. In year 2, we have some incomes. What are the incomes that we have? The interest from bond 1, the interest from bond 2, and the interest from bond 3. They are our income. And also another things that we have the interest and the deposit S1 that we make at the beginning of year 1. So when at the beginning of year 1 we put S1 into account, at the beginning of year 2 we would have 1.04 S1. Why? Because S1 was the initial deposit plus 4% of interest of this one, S1, so the total would be 1.4 S1. So that's the things that you see here. This S1 times 1.04 is the amount of money that you paid, that you invest in saving account at the beginning of year 1 and at the beginning of year 2. After 1 year, you are gonna get the principal of your money plus interest. So it is calculated as 1.04 S1. So all the things are the incomes you have. And how much you need to pay? 210. It is the cost that you have. Also, you have another things. The money that you want to invest in saving account another time. And when you have all these things, the mass would be something like this. The income from bond 1 plus the income plus the income from bond 2 plus the income from bond 3 plus the principal and interest of money you invested in saving account minus the amount of money you want to invest in saving account at the beginning of year 2, all of these things must equal to 210. What's the point of this? It guarantees that with this amount of income that you have, you can cover your obligation at the beginning of year 2. And remember, B1, B2, B3, S1, S2 are all decision variables, and the computer and the mathematical model and the decision science itself specify these numbers, because when with human intelligence we try to figure it out, what about the numbers, we cannot, but computer will do it easily. We start solving these models also very soon. So as a explanation on this type of things, let's do it quickly together. It is year 2. For year 2, you have some expenses, that is 210, the amount of money that you need to give to the people who retired sooner at the beginning of year 2. You have some incomes that you need to cover these expenses with these incomes that you have. Also, you have new investment, because it's a financial planning. It's a horizon of 7 years of investment, and so at the beginning of each year you need to decide about the new investment options you have. You may ask why we are not considering reinvestment of bonds, because for bonds you invest only one time at the beginning of year 1, and after that you just enjoy the interest from bonds and the par value. And after that you decide here how much you are gonna invest in saving account. The amount of investment you have in saving account and also the obligations you have, all are fueled by the income you have. But with this constraint, you are sure that you can cover your obligation on year 2. Since we want to be sure that year 3 is also we cover the obligation, we are gonna through the same type of analysis. So please stop the video here and try to draw the same thing as you see here. Just instead of 2, in your case should be 3, and try to draw a similar diagram and create the monetary demand of year 3. Because very soon I'm gonna show it to you. So here stop it, because now I'm gonna show you the diagram for that one. Okay, it is the diagram for year 3. Now we are here. We want to make sure we cover our obligation regarding year 3. We need to pay to the early retired personnel. We had 222, and the rest, as we can see, is to a high degree the same. The amount of interest from B1, B2, and B3, and also the income we have from the saving investment. The only difference is that since we put S2 at the beginning of year 2, the amount of income that we have here is 1.04 S2, and it is the amount of investment at the beginning of year 3, and this is our obligations. So it is the one that very easily now you can make the for me